Hello, welcome to our channel. In this video, we will talk about domain and range of functions. First, let's quickly define what we mean by domain and range. So basically, domain is the set of all possible input values or X values, and range is the set of all possible output values or Y values. And these are the two things that we need to be careful about when finding domain and range. The first thing is that we want to avoid dividing by 0. So that is avoid the values of X that makes the denominator 0. So for example, if you have a function like 1 over X, we can't have X equal to 0. So we must have X not equal to 0 in the domain. And we also want to avoid square root of negative number. So for example, if you have square root of X, then X must be at least 0, 0 or greater than 0. So if we keep these two things in mind, then we can basically find domain of almost all algebraic functions. So let's look at some examples now. So here is the first one. We are given f of x equals x squared plus 1. So we need to think what values x can take. If you look at this function, we have x squared. We can square any real number. So the domain is all real numbers. So set of all real numbers. Which we also denote by R. The set of all real numbers is denoted by R. And if we put this in number line, we have 0 right here. So we are considering everything from this end to that end. So at this end, we have negative infinity. At that end, we have infinity. So this we can also write as everything from negative infinity to infinity. And we never include infinity and negative infinity because we don't really know what they are. So we need to use parentheses. So this is the domain of this function x squared plus 1. Let's look at the next example now. So here we have square root of x. So like we said earlier, anything under square root can take only non-negative values. So in this case, domain is all real numbers. That are not negative. So basically, we can write this as x is a real number such that x is greater than or equal to 0. So this is the domain. If we want to put this in a number line, our 0 is right here. So we are looking at all the values from this point all the way up to infinity. So from 0 to infinity. So this we can write as 0 to infinity. And we use square bracket at 0 because we are including 0. And we can't include infinity. So we use this parenthesis here at infinity. Look at another example now. So we have this function 1 over x plus 2. Now the problem here is we have some expression in the denominator and we want to make sure that the denominator is not 0. So this part will be 0 if x plus 2 equals 0. So which means x is negative 2. So this is what we want to avoid. So that means domain is all real numbers except negative 2. So this we can write as x is an element in the set of real numbers such that x is not -2. Now, if we put this in number line, let's see how that looks like. 0 is somewhere here and -2 is here. So we can include everything, all these numbers, except this one here. So we can come from -infinity all the way up to -2. And after -2, we can go to infinity. So basically, we need to remove this number, and then we can again continue from here. So the domain would be -infinity to -2, and we don't include -2. Union, again, we start from -2 without including -2 to infinity. So this is the domain of this function. And here is another example. We have 2x squared plus 6 over square root of x plus 2. Now this top part is okay. We can have any real number here. We can square any real number, multiply by 2 and add 6. But we have some issue in the denominator. We have square root of x plus 2. So because it's in the denominator, we must have square root of x plus 2 not equal to 0, which is same as saying x plus 2 not equal to 0. And we must have x plus 2 non-negative, so greater than or equal to 0. So this says x plus 2 is not equal to 0. This says x plus 2 is non-negative. So if you put these two together, we must have x plus 2 positive. So this is same as saying x is greater than -2. So that means the domain is all real numbers greater than -2. And negative. So this we can write in the set builder notation as x belongs to the set of real numbers such that x is greater than -2. Now let's put this in a number line. -2 is somewhere here. So we are looking at all real numbers greater than -2 and not including -2. So these numbers from -2 all the way up to infinity. So this we can write as -2 to infinity. This is the domain of this function. Let's look at more examples. So here we are given functions and we are asked to determine the domain and range. So we simply need to look at for what values the function or the graph is defined. So in this case, so if you look at the graph of this function here, so it looks like it's extending to both sides. So we can have any x value as input. So it's taking all possible real numbers as x values. So the domain is the set of all real numbers, which we can write as also as -infinity to infinity. So we can have any real number from -infinity to infinity along the x-axis as the function. Basically, this graph covers all x values. So that would be the domain. Similarly, for range, so we need to look at what y values the graph covers. So it looks like, for example, if you think of this y value, we don't have a point corresponding to this y value. So this is not in the range. If you think of that y value, so we don't have point for that y value also. But if you think of this y value, we have a point right here for this y value. So this is in the range. So it looks like the y values start from here and go all the way up to here. So from -1 to 1, the range is from -1 to 1. So this is simply all the y values hit by the graph. So let me write that down. That is the range, and all the x values hit by the graph is the domain. So let's try the next one now. So over here for domain, again, we look at all the X values hit by the graph. So it looks like the X values start from here, but not including this one because we have a hole. So from -5, not including -5, it goes all the way up to -2. And the numbers between -2 and 0 are not included, but 0 is included. So union 0, and all these X values are included. So it goes all the way up to 5, but not including 5 because we have a hole over here. So that's the domain. So it's simply all the X values hit by the graph. And the range is, again, all the Y values hit by the graph. So these Y values, none of these are hit by the graph. We don't have any graph for these Y values. So it looks like the graph starts from Y value 0. And it goes all the way up to 2. So this is the range. So let's try the last one now. So domain again is all the X values here. So since this graph extends to -infinity on this side, the X values here start from -infinity. It goes all the way up to 1 over here. We don't include 1, so we have to stop there. But we can include everything after 1 again, because we have graph for all these X values, 1 to infinity. So this is the domain. And the range is, again, all possible Y values. All these Y values are included. So the Y value down here is -infinity. We can go all the way up to 0, but 0 is not included. We don't have any graph for Y equals 0. So -infinity to 0, union, and then we can again start from 0 and go all the way up to infinity for Y values, 0 to infinity. So this is the range for this function. All right, a few more examples here. So again, the domain is all possible X values. If you look at this one, so all these X values are included because this graph extends indefinitely on this side. So we can start from -infinity, which is somewhere over here. And we can go all the way up to 1 right here, but not including 1 because we have a hole over here. So this is the domain, all possible X values. All these X values are taken by the graph. And for range, we look at all possible Y values. You see, none of these Y values are taken by the graph. There is no graph over here. So none of these Y values are considered. But we have graph from this Y value onwards, from 0 to infinity. Because all these Y values contain some part of the graph. Okay. Now for the second one, again, domain is all possible X values. So it looks like in this case, these X values are not taken by the graph. So we didn't include those. It looks like it's starting from 0, but 0 is not included. Since the graph never touches the Y-axis, this X value is not included in the graph. So the domain will be 0 to infinity. Infinity is somewhere over here. So all these X values make the domain. And similarly, the range is all possible Y values. Since this graph extends indefinitely, so Y values start from -infinity. And again, this is also extending indefinitely, so it goes all the way up to infinity. All these Y values are included in the graph. So for example, for this Y value, we have that point and so on. So this is the range. The last one here. Again, the domain is all possible X values. So it looks like for this graph, X values go from that point to this point here. From -2 to 1 is the domain. And we can include -2 and 1 because we have solid dot here. That means that these endpoints are included. And the range is again all possible y values. It looks like the y values start from here, which I would say is -1, and it goes up to here, so which is 3. This is the range here. Right, so we are done with these examples. Hope it was helpful. Please subscribe to our channel if you haven't already. Thank you.